guys. So today we're going to be looking at working with radicals and solving quadratics by taking the square root. So the first thing is we're going to be looking at simplifying radicals. So quick review on radicals. A radical is any expression that has a square root, cube root, or anything like that. Again, the radical symbol is this. So that would be our square root. Generally, we don't put our number with the square root, but there is a 2 there, and it's an understood 2. Just like if we ever have the variable x, we know the coefficient on it is 1, we don't put it, and we know its exponent is also 1. The square root has an understood 2. That's the degree of the root, or the index of the root. So other roots would be like our cube root, or the third root, or fourth power of that root. Fourth root, fifth root, anything like that. The 2 is understood to be there when we're talking about the square root. So then let's talk about our perfect squares. So our perfect squares are 1, 4, 9, 16. I extended that all the way up to our 15th power. So like this would be 1 squared, 2 squared, 3 squared, 4 squared, and so on.
Is that 64?
Yes, 64, 81, 100, 121, 144, 169, 196, and 225. So that goes up to 15 squared.
Wait, so what's the x2, x4, x6, x8? Is that x10?
Yes, so we also have perfect squares when we're talking about variables, when we have exponents. So x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, x to the 12th. An exponent or a variable with an exponent is a perfect square as long as that exponent is even. So any even exponent is also a perfect square. Okay. So with that in mind, we can start simplifying these radicals. We're simplifying these square roots. So case 1, this would be the ideal case. You just have a perfect square. So then you take the square root of the number or the variable, and you're done. But generally, that's not going to be the case. We're going to have non-perfect squares. So what we want to do is we want to break them into a radical that is a perfect square and a non-perfect square. We want to take out the biggest perfect square possible. And then whatever we have left over will just stay underneath the radical. For both cases, if there's a coefficient outside the radical, we're going to multiply by that number that's out front, that coefficient. So let's work through some of these. So number 1, we just have the square root of 49.
That's 7, right?
We get 7. So we just take the square root of 49, we get 7. Right, 49 is one of our perfect squares.
Wait, and the answer is 7?
The answer is just 7. We just simplify it down, we get 7. Number 2, we have the square root of 225. 15, right? 225 is another perfect square, so we get 15. Then we have number 3.
12? Oh, yeah. Am I right? 12? Oh, you got 2 in the front.
So we have a 2 in front, so we have that coefficient of a 2. Square root of 144 is 12. So then we're going to have 2 times 12, so then we get 24 as our simplified value. Right? Square root of 144 gives us 12. We have that coefficient, so we multiply those two. We get that 24.
Yes, sir.
If we have a fraction, so right now we have the square root of 4/9. We really can't have a fraction in the square root, but we can also kind of think of it as that square root is on both the top and our bottom. So we're in our numerator and our denominator. What is the square root of 4? 2. The square root of 9? 3.
And that's your answer?
That's our answer. So number 5, square root of 1 over 81.
So 1/9?
1/9. Okay. We'll go ahead and do number 6.
Would it be 6/11?
Yes, it would. And we would reduce if we could. In this case, we cannot. Okay.
Wait, so don't reduce it, just leave it like that?
Yeah, 6/11 doesn't reduce. So neither did any of these others. So then let's look at number 7. So number 7, here's where we don't have that ideal case. We have the square root of 112. So when we look at our perfect squares, we go from 100 to 121. 112 is not a perfect square. So what we want to do is we want to find the biggest perfect square that is a factor of 112. So if you don't know the factors of 112 easily, we can go to our calculator. We're going to use this nice little trick. Go to y equals. I think you don't see that at all. But we go to y equals. We're going to take 112 and we're going to divide it by x.
Wait, so you just punch in the X?
Yes, so y equals, and then type in 112, divide by x. And then we want to go to second graph. So second table, this top right gray one. That's going to open up our table for all of our factors. And what we want to do is we want to find one of these that we can use in our division. So starting at 1, we got 112, 2, 56, 4, and 28. So 4 is a perfect square, but 28, I think we can do better than that. 7 and 16. So 16 is a perfect square, 7 is a prime number. So we want to split this 112 to the biggest perfect square possible, which would be 16 times 7. So 16 times 7, that gets us back to this 112. But now we can take the square root of the 16. We get 4. So simplified, we have 4 square roots of 7.
Can you show me that calculator trick again? Come on.
And we don't have to multiply those in the answer? Like you said?
No. So once we come out the radical, we stay outside. So this number is just going to stay out front. That's going to stay on the inside. It's a leftover.
So it's y.
So y equals, and then type in whatever number we were looking for. So we were trying to find factors of 112. So I did 112 divided by x.
And then what do you do after that?
And then second and graph. So the blue button, and then your top right gray button.
I'm so confused.
So y equals,
No, I got that part.
oh, you got that part
It's just the whole,
of the whole
Okay,
thing.
I got it.
yeah, the 16 and 7, where that 7 isn't on the list.
Yeah.
7 is prime. So what we were looking for was 16. We wanted that number. Okay. So we're going to keep doing these. We're going to keep doing this. So number 8.
Is that a non-perfect?
It is non-perfect.
Okay, well, you will think it.
So we're looking for a perfect square that goes into 245. So we're looking for one of these. So if you don't,
Second graph.
so 245 divided by x. So looking down, kind of looking in this row, 49 is one of our perfect squares, right?
Yeah.
So 49 times 5.
Does 49 go first?
I always put my perfect squares up front because that number is going to end up out front.
And then it'll be 7 with the square root of 5.
There we go. So the square root of 49 gets a 7, and that radical 5, that square root of 5 just stays. It's our leftover.
And that's all we're doing today?
Not quite. Okay, so are there any others?
What about 9? The 72, like the 72 is a non-perfect, right?
Yep. 72 is non-perfect, so 5 times square root of 72. So we want to split 72 to the biggest perfect square possible and non-perfect square. My 5 is just going to travel down.
Oh, okay.
So it's just going to stay out front for now.
And then you do like the X thing on your calculator.
Mhm.
And, you know,
Hold on, Jake, we can't say this. I was already talking.
I'm not, okay, hold on. Yeah, I'm still not saying it, hold on.
Anybody else have it?
9.
No, it's 36, 2 and 36.
So 36 times 2 gets us 72. And then what we want to do is square root of 36
That's 6.
gives us 6. And that 5 that was out front is now going to be multiplied by that 6. So we have 5 times 6 is 30, square root of 2. Any others we want to do? Okay, so that's how we do our numbers. Okay. We also had our perfect squares with variables. So if we flip our paper over, now we have variables included. Now again, our variables are perfect squares as long as they have an even exponent. So the way we're going to work with our variables, very much the same as what we were doing with our numbers. In this case, we have a to the 6th. So the first thing we want to do, whenever we take the square root, we're really raising a power to another power, which means we multiply. In this case, again, we have that 2 there. We're raising this 6th power to the 1/2 power, or we're essentially dividing this exponent by 2. So when we have a to the 6th, the square root of that, take your exponent, divide it by 2, we get a to the 3rd.
Wait, that's the answer?
Mhm.
So you just divide, if it's even, you just divide the exponent by 2.
So if it's even, divide your exponent by 2. So we have a to the 6th, b to the 10th.
So that'd be A, 3, B, 5, right?
That's exactly right. So the variables, again, take your exponent, divide it by 2. There's your perfect square, right? As long as they're even. Now, if they're not even, so looking at number 4, we have the square root of
7.
b to the 7th. What we want to do is we want to split it like we were these numbers. We want to get the biggest perfect square possible and some leftovers. Yes.
I'm like, number 3 would be A2 and then B6. But you have to set 5 to 6 again.
Once you do it once, you're done. Lesson. So we have b to the 7th. We want to split it into the biggest perfect square possible. So that would be 1 less than what we started with. So b to the 6th times the square root of b. So just like we were doing with our number, right, biggest perfect square, our biggest perfect square is 1 exponent lower than what we started with. So subtract 1, and that 1 that you took out is going to be left under the radical. Now we can take the square root of this, that b to the 6th, we get b to the 3rd.
Wait, the square root of 6?
B to the 6th,
Oh,
that exponent. So then we get b to the 3rd times the square root of b.
are you saying divide by 2 with the 6?
Mhm.
Okay, I thought you meant square root of 6, because 6 don't have a square root.
So let's look at number 5. So we have m to the 11th. So again, we want to take 1, we want to split it away. That's going to leave us with m to the 10th under a radical and an m. Right, m to the 10th times m gets us that m to the 11th, so those are still equal. But now we can take that square root, because we have that even exponent, divide it by 2. So That's going to give us m to the 5th times square root of m.
What happens if you have to take what happens if you had to take 2 away? Like, would you put M2? Like, if you had to take 2 away?
You wouldn't have to do two.
I know what, let's say you didn't.
Well, if you did, so
That's what I was saying, like, is there gonna be one like that where you take like 3 away or something?
you'd only ever want to take away 1, because you're only ever 1 number away from an even exponent. I mean, if you did, you could still keep going and it'd still end up correct. But all you need to do is just take away 1. Okay. So let's look at some of these that have mixtures. So number 7, we've got the square root of 9 and the square root of a squared. So 9a to the 8. So even though we have a mixture of numbers and variables, square root of 9, 9 is a perfect square, and a to the 8 is also a perfect square. Square root of 9 gets you 3, a to the 8. See that, a to the 4th. Okay.
So, square root the actual number and then just divide by 2 for the next one.
And that's if they're perfect squares. Number 8, however, again, is not a perfect square. So we have the square root of 45a to the 7th. So again, what we want to do is we want to split it. 2 radicals, 1 with the perfect squares and 1 for our non-perfect squares. So we need the biggest perfect square that goes into 45. What would that be? 9 times 5. 9 times 5 gets us that 45. And then we have that a to the 7th. We want to split it as well. So the biggest perfect square that we can split that into, a to the 6 times a. Here's our perfect squares. We have our non-perfect squares. So square root of 9, 3, a to the 6th,
A straight.
a to the 3rd, and that square root of 5a just stays square root of 5a. Okay. Any questions on that?
I don't think so.
Are there any more of those that you wanted to do?
About 10.
So let's look at 10. $32, 87. And 4. Okay, so again, first thing, we want to split it. Perfect squares and non-perfect squares. 32, what's the biggest perfect square that goes into that?
84. I went 6 and 6. Okay.
So 8 and 4 gets us close, but we can go a little bigger. 16 and 2. And then a to the 7th will be split into a to the 6th and a. B to the 4th is already a perfect square, right? Even exponent, so it just goes in this first one.
And then you simplify more.
Yep. So simplify more, take the perfect squares, take the square roots of those. So 16 becomes 4. A to the 6th is A3, and B to the 4th,
B2.
B2. And we have our leftovers, 2A. And there we go. So that's our simplifying radicals. I'm going to give you guys about 10, 15 minutes to work on this part of the homework, and then we'll go to the next lesson.